Welcome back, guys. In today's video, we'll be learning how to divide binary numbers. Let's get right into it. Division of binary numbers can be done in two ways. In the first method, we're going to divide directly in base 2. Let's do that using the two examples that we have on our screen. To do that, we'll be using the long division method. The long division method involves 3 steps. That is divide, multiply, subtract, and then you repeat. So I'm going to write the first number here, 1110 in base 2. And then I'm going to write the second number, which is the divisor, 10 in base 2. So this is the dividend and this is the divisor, and we're going to go ahead and divide. So we'll be using the first two digits here. Of course, we know that 1 divide 10 is not going to go through, so I'll take the first two digits 1, 1, and when I divide that by 10, I'm going to get 1. So I've divided. Next, we're going to multiply. 1 times 10 will give us 10, and the next step is to subtract. So when I subtract 10 from 1, I'm going to get 1. Please do well to check out our video on subtraction of binary numbers if you don't know how to do that yet. So basically 1 minus 0 will give us 1. 1 minus 1 will give us 0. Since the 0 is insignificant, I'm not going to write that. Now 1 divided by 10 cannot, so I'm going to bring down 1. Bring it down here, and then I have 1, 1. Again, we repeat the process of divide, multiply, and then subtract. So 1, 1 divided by 10 will give me 1. 1 times 10 will be 10. And then let's subtract. So 1 minus 0 will be 1. 1 minus 1 will give us 0. It's insignificant, so I'm not going to write that. 1 divided by 10 cannot, so we're going to bring down the last digit here, which is 0. And bring it down here, and now we have 10. Of course, 10 divided by 10 will be 1, which I'll write here. 1 times 10 will give us 10. So we subtract, and then 10 minus 10 will give us 0, and we are done with this division. So our final answer is equals to 1, 1, 1 in base 2. We're going to do the same for the second example that we have here. We're still employing the long division method, and that's divide, multiply, subtract. Just have that at the back of your mind. So I'm going to draw the line here. The divisor is 1, 0, 1 in base 2. And then the dividend is 1, 0, 1, 1, 0, 1 in base 2. So we have 3 digits here, 1, 0, 1. So I'm going to start this division. I'll take the first 3 digits and do the first step of our division, because we know 1 divided by 101 cannot. 10 divided by 101 cannot. So 101 divided by 101 will give us 1. I'm going to write that here above the third digit where we started this division from. Next step is multiply. 1 times 101 will give us 101. Let's subtract. You know that if we subtract this, 101 minus 101 is going to give us 0. and we can't divide by 0. So I'm going to bring down the first digit here, which is 1. Now 1 divided by 101 cannot. So we're going to have to write 0. Now normally I'll repeat the process of multiply and subtract, but if I say 0 times 101, it's going to give me 0, and when I subtract I'll have 1, and I'm still going to have to deal with a 1. So I'm not going to do the multiplication and subtraction here because I'm going to keep getting the same result of 1. So I'm just going to go ahead and bring down 0. So you know that this first 0 here is insignificant. I'm only going to be considering 1 0. Again, 10 divided by 101 cannot. So I'm going to have to write 0 again. If I say 0 times 101, I'm going to get 0. If I subtract, I will still be left with 10. So I'm not going to bother to do the multiplication and subtraction step here. Instead, I'm just going to go ahead and bring down the last digit, which is 1. When I bring this down, I have 101, which I can now divide by 101, and I'll get 1. 1 times 101 give me 101. And then when I perform the subtraction, I will get 0. So it means that 101,101 in base 2 divided by 101 in base 2 is equal to 1001 base 2. So that's it for the first method of division using the normal long division method that we know. Now for the second method that we can use to divide binary numbers, it involves converting the binary numbers to base 10, performing the division in base 10 and then converting our result back to base 2. So this is the first example that will be solved using long division method. Let's go ahead and attempt the same example using the second method. So to do that, I have to convert 1110 in base 2 to a number in base 10. Now, if you don't already know how to do this conversion, please check out our video on conversion from base 2 to base 10. So I'm going to indicate the powers here. We have 0, 1, 2, and 3. So I'm going to expand this by multiplying each digit here by base 2 raised to the power that I've written above the number. So I'm just going to start doing that down here so I can fit it all on one line. So I have 1 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 plus 0 times 2 raised to the power of 0. The next step, I'm going to solve for the powers. This will be 1 times 2 raised to the power of 3 will give me 8. That's 2 times 2 times 2 plus 1 times 2 raised to the power of 2 will give me 4. That's 2 times 2 plus 1 times 2 raised to the power of 1 will give me 2 plus 0 times 2 raised to the power of 0, and that's going to give me 1. Remember that anything raised to the power of 0 will give you 1. The next step, we're going to multiply. 1 times 8 will give me 8 plus 1 times 4, which is 4, plus 1 times 2, which is 2, and then 0 times 1, which will give us 0. Now if we add this, we know that 8 plus 4 is 12, and plus 2 will give us 14. So we've converted the first number. We're going to do the same for the second number here, which is 10 in base 2. So indicate the powers, we have 0 and 1. To expand, this is going to be 1 times 2 raised to the power of 1 plus 0 times 2 raised to the power of 0. We work for the powers here. We have 1 times 2 raised to the power of 1 is 2 plus 0 times 1. Now let's multiply that. We're going to get 2 plus 0, which is equals to 2. Now that we have succeeded in converting both numbers to base 10, we're going to write that as 1110 base 2 divided by 108 base 2 is equal to, we have 1110 as 14, and then we have 10 as 2. And we know that 14 divided by 2 is going to give us 7. So we're not going to leave our answer in base 10 since the question was given to us in base 2. So let's go ahead and convert 7 back to base 2. And to do that, we are going to perform a repeated division of 7 by 2, and we'll store the remainder. Do well, check out our video on conversion from base 10 to base 2 if you don't already know how to do that. So we're going to say 7 divided by 2. That's going to give us 3 remainder 1. Now, as a hint, every time you divide an odd number, you're going to get remainder 1. But if it's an even number, you're going to get remainder 0. So just keep that at the back of your mind. And again, 3 divided by 2 will be 1 remainder 1. And 1 divided by 2 will give you 0 remainder 1. And even though either ways this is going to be the same, always bear in mind that we write our remainders in this direction from down to up. And we're going to finish up here by saying 1110 base 2 divided by 108 base 2 is equal to 1118 base 2, and that is our final answer. So this brings us to a close on our lesson on division of binaries as well as our binary series. Check out our other videos on binary numbers, conversion of binary numbers from base 2 to base 10, also conversion from base 10 to base 2, addition of binary numbers, subtraction of binary numbers, and multiplication on binary numbers. That's it for our lesson today, guys. As always, I've got a bit of classwork here for you to do. Feel free to try that in your spare time, and if you want them to be looked at or graded, you can send it to the email on your screen, mathswithmrsspace@gmail.com. I'll be happy to go over them and send you feedback and corrections. Thank you for watching. Do well to like our page, share and subscribe. Turn on the notification button so you will know when we put out a new video. Thank you. See you in the next one.